We can prove that the bin packing problem is NP-hard by reducing it from the subset sum. Say we have some items of sizes S1 to S4 and a bin of size T. Now, if we choose to normalize all these values by the size of the bin, we get the standard form of the bin packing problem, where the size of the bin is 1 and each item's size is less than 1. Now, the subset sum problem states that given a set of integers a1 to an and a target t, does there exist a subset of those integers that sums exactly to t? Now we can turn this into the partition problem really easily because it is just a special case where the target is now exactly half of the sum of all the sizes of your elements. So if we take our example, our bin size now becomes 7, which is half of the sum of all a1 to a4. Notice that we can rephrase this into a question that asks, can we pack the items into two bins whose size each is the total sum divided by 2? If we do pack the items, what if we now normalize them by dividing their sizes by the size of the bin? This turns into an instance of the bin packing problem, and the optimal number of bins is equal to 2 if and only if the answer to the partition problem is a yes, which is an NP-hard problem. So by the transitivity of reductions, we've shown that the bin packing problem is also NP-hard. A nice outcome of this reduction is that we are able to prove the lower bound of alpha for approximation algorithms. Let's assume A is our algorithm with an approximation ratio less than 3 by 2. The output S given by our algorithm A has to lie between the optimal value and alpha times the optimal value. Using this inequality, we get two cases to consider. In the first case, the optimal value is equal to 2, and so our output S is also 2. However, if the optimal value is greater than 2, then our output S is also greater than or equal to 3. Based on the value that S takes, we are able to solve the partition problem using our approximation algorithm A, which implies that P equals NP, which is not possible. And thus we conclude that 3 over 2 is our inapproximability baseline that we have for any approximation algorithm that can solve the bin packing problem.